Hello, welcome to ICCT Online Learning. For today's video, we're going to discuss about the integration formula. The objective of this topic first is to evaluate different integration concepts, simple power formula, simple trigonometric function, logarithmic and exponential function. Second one is to practice different theorems of integration to evaluate function. Let's define what is antidifferentiation. Antidifferentiation is a function that reverses what the derivative does. One function has many antiderivatives, but they all take the form of a function plus an arbitrary constant. Our basic rules are the constant multiple, the power rule, sum and difference, and exponential rule. First, let's have the example under the constant multiple rule. Under the constant multiple rule, we're going to follow the integral of k f of x dx is equal to k integral of f of x dx. So for our first example, we have the integral of 2x dx. So again, our example is the integral of 2x dx. So applying the constant multiple rule, we're going to separate the coefficients to the bar. So we have 2 integral of x dx. Then let's apply the integral. So 2, then copy the variable, add 1 to the exponent, and if what our exponent, that would be also our denominator. Then add the arbitrary constant. It is came from this formula, the x raised to n plus 1 over n plus 1 plus the arbitrary constant. Then let's simplify. So we have here 2x squared over 2 plus c. So by getting the common term of numerator and denominator, which is 2, the remaining is x squared plus c. So that would be the answer of the integral 2x dx. Next basic rule is a power rule. So we're going to follow this method. The integral of x raised to n dx is equal to x raised to n plus 1 over n plus 1 plus c, or the arbitrary constant, wherein n would that be equal to negative 1. So for the example number 2, we have the integral of 2x cubed dx. So again, our given is the integral of 2x cubed dx. So by applying the power rule, or we can rewrite this one into a constant multiple rule by having the 2 integral of x cubed dx. Then applying the power rule. So again, the power rule formula is the x raised to n plus 1 over n plus 1. So by adding 1 on the exponent, we have 4 here, and we have 4 also here. Then by adding the arbitrary constant c. Then by getting the common term of the numerator and denominator, or simply as 2 and 4, common number is 2. So 2 would become 1, 4 would become 2. So we have here 1/2 x raised to 4 plus c. So that would be the answer for the integral of 2x cubed dx. Third one is the sum and difference rule. So for the example, the integral of 9x squared dx plus the integral of 7x dx. And again, our given is 7x squared dx plus 9x dx. So applying the sum, okay, the sum rule of the integral. So as you can see, it is in a polynomial form. Okay, so we may use also the other rule, okay, for the integral. So we have here the 7 integral of x squared dx, okay, plus the 9 integral of x dx. Then by applying the power rule, okay, to x squared, by adding 1 on the exponent, we have x cubed over 3 plus 9 times x squared over 2 plus the arbitrary constant. Always put the arbitrary constant c. By simplifying, we have 7 over 3 x cubed plus 9 over 2 x squared plus c. So that is the answer for the integral 7x squared dx plus the integral of 9x dx. Then lastly is the exponential rule. So we have two methods that we can use in evaluating exponential function. First is the integral of e raised to x dx is equal to e raised to x plus c. We have other one, which is the integral of a raised to x dx is equal to a raised to x over ln, or the natural number of a, plus c. So this is our given. The integral of e raised to 2x dx. Yeah, so again, our given is the integral of e raised to 2x dx. So based on our method, under the exponential function, that is equal to e raised to x dx. So based on our given, the integral of e raised to 2x dx, we have here the e raised to 2x over, okay, 2, okay, if what would be the number here, plus the arbitrary constant. So we can rewrite that one as 1/2 e raised to 2x plus c. So that would be the answer for the integral of e raised to 2x dx. That would be all. I hope you've learned a lot from this video. Thank you. See you on next video lecture.
For more ICCT College's video updates, please subscribe and click the notification button.